So 3 days ago I talked about ICPC, and I think the key difference is that for ICPC, most is based on that students are very willing to come to trainings and so on. And for IOI, it is not always true, because many high school students just don't know whether they want or not come to these trainings, and those decisions are up to their parents in the end. And well, and all this means that in order to, in order to be more friendly to high school students, basically everything is done for them. So when we prepare for ICPC, when they have to prepare contests, they have to spend time at night solving problems that they didn't solve at the contest, and so on. For IOI, there is nothing like that. So basically, for IOI, we want to give good training even to high schoolers that don't want to train themselves. But if they come to our Olympiad and do well, then we want to try to give them training, at least try. So it is kind of, more, we are more willing to help them than students. And that's because all IOI training process is, it is a big system, but in almost all places it is sponsored by government. So it is like high school Olympiads. We have, in Russia, we have a law about high school Olympiads that defines the Olympiad somehow, and that allows you to get to the university without exams if you do well at high school Olympiads. So all these Olympiads are official. So what Olympiads do we have? Usually we have 4 levels. So usually it starts at a city Olympiad. In a city Olympiad, usually either everybody can participate who wants to participate, or there is a limit. For example, no more than 2 persons from high school, something like that. But generally, there is no selection for city Olympiad. It means that basically it is kind of open. It is not open because we might not have enough computers to run the Olympiad. So from the city Olympiad, you can get to your regional Olympiad. Region is, so Russia is split into 85 regions. Then you get to district Olympiad. So here we have 85 regions. Here we have 10 districts. And there is some confusion, because sometimes before City Olympiad, for example in Moscow, there is also a district Olympiad, but this district has other meaning. So Moscow is split into several districts. So sometimes, I don't know, let's name it in some other way, like, I don't know, sub-City Olympiad. But that's only true for large cities like Moscow. And then you get to Russia Olympiad. And from Russia Olympiad you get to IOI team selection. And if you are lucky, you finally get to IOI, which is the old path that you can take. In some regions, some of those Olympiads are absent. So for example, for Moscow, we have the sub-city Olympiad, then city Olympiad, and then directly to Russia Olympiad, Moscow. That's because Moscow is a region by itself in Russia, so we have 85 regions, one of them is Moscow. And we don't participate in district Olympiad, I don't know why, but it just happens so. But for most places you have this chain of Olympiads. Each of those Olympiads uses problems that are quite like what we solve here, but easier. So usually, in order to pass several first levels, you only need to have a talent. You don't need practice. So, I mean, I don't know. So, example problem of, I don't know, city Olympiad would be, I don't know, given n up to 100, bring 2 to the power of n. So you have to write addition of long numbers. Problems like that. So generally, if you have 5 hours of 3 such problems, even if you don't have experience, you hopefully can write something. And scoring is also not like an ICPC, but like an IOI. So you get partial scores if you pass some test cases, but not all. So, yeah, so that's the chain. So, what are the interesting parts? IOI team selection is a 2-week camp. 2-week camp. Where every day there is a contest in the morning, that's just like here, and after the contest there's usually a lecture. But the difference is that their lectures are not about problems usually, but not about problems of the contest, but in most cases about some topic like dynamic programming or string theory or graph theory or something like that. So there are lectures on dedicated topics that basically teach you some basic algorithms in all those areas. Sometimes there is problem analysis, but usually it is done like one problem analysis for 3 or 4 days. Because there are only 3 problems per day, you can do that. And then IOI team is selected by adding the results of Russia Olympiad and each of the days of the camp. So each problem costs 100 points. So basically Russia Olympiad, it has 2 days of 3 problems. So we have 2 days of 3 problems. And here we have 12 days of 3 problems, and together these 14 days, you get a total score, and usually the top 4 is selected to go to IOI based on this score. So in most cases, it is this camp that is about selection, not Russia Olympiad. Because even if you do very well here, if you don't do well at the camp, you will lose. Sometimes all this system is also present in all other areas, like in mathematics, in physics, in chemistry, in Russian language. There is also such structure of Olympiads. And they are all government supported. But the difference of informatics is that in all other Olympiads, they are separate by grade. So in last year of school, you have Olympiad for those who are in last year of school. Then you have Olympiad for those who are next to last year of school, and so on. So depending on your grade in school, you compete with people of your age. And in informatics, there is just one. So you compete with all people that compete in this Olympiad. Because of this, it is quite normal to participate in these Olympiads, not in your last year of school. And because of this, the IOI team selection process also somehow, and actually the selection process on all levels does take this into account. What do I mean? For example, from city Olympiad to regional Olympiad, usually there is some number for each city, like top 7 people, but usually it's formulated like this, like top 5 people plus top 2 people in not more than 9th grade, so that have at least 2 more years to study. So usually all the system encourages young participants, even if they don't perform to get to the next levels, you can still get to the next level. So for example, when I was participating in all this for the first time, I got to this stage only because of this rule. Otherwise I would have failed on this stage, if not for this rule. So in every Olympiad I was in the middle of the results basically, but because I was very young, they took me to the next level. So I was lucky about this. But it turned out quite well, so the system kind of works, yeah. So even at this stage, it is still used. So for example, last year, the Russian team to IY was selected, and first 4 places were guys that were in the last year, and the 5th place was guy in next last year. And so we took first 3 and 5th place to the IY. Of course, it seems unfair to the guy in the first place, but that's how it works. There is no formal published rule, unfortunately, for this. So basically, each time the decision to take younger guys is kind of arbitrary. So it is taken by whoever runs the Olympiad or selection. And that guy who is next last year got the only gold medal for Russia. All others were silver or bronze last year. So, yeah. Okay, so this is the general picture. So what about the problems? As all that I've written here is sponsored by government, you are usually paid for certain problems for these things, and all problems are new in these competitions. Sometimes, so all this is usually run by students like you that are participating in ICPC. So most of these problems and all those contests, most problems are created by university students. Sometimes there are some regions or even cities where there is nobody who has participated in programming contests, but they get a request from, basically there is some I don't know, some symposium of all informatics teachers, and they say that, okay, we need to run a city informatics Olympiad, and nobody knows what to do. In this case, there are some funny Olympiads, like you need to draw this picture on the screen or something like that. Such problems appear in low-level Olympiads sometimes. But luckily, clever students can draw a picture on the screen, and then they get to the next level, so then they get normal problems. But yeah, we have this problem. So yeah, so this is the official part. Some cities organize a team selection for Russia Olympiad or some regions. So again, for example, in Moscow, here actually there is a Russia team, Moscow team selection. It was not like that when I was participating, but these days they have a 1-week camp that also follows this format and is used to select the team for the Russia Olympiad. In other places it would be a region team selection, for example. All this happened because of recently, as I said, there was a law that people that go to the Russia Olympiad and get a diploma there, and to get a diploma you need to be in the top half of the participants. You get admitted to any Russian university for free. And that's quite a big advantage. So, how to say? Maybe people become interested in Olympiads, even though those people that they were not participating in them when it was just for fun. And because of that, these new training camps and so on. So many more preparation takes place now. Okay. So I think that's about it about the official part. Yeah, I should probably take more about this, as I think this is the most important part. For me, this was where I learned everything that I know, basically. So I was there 6 times, and each time I learned something new, because each time there were different teachers, and those teachers are again usually university students who participate in ICPC. But again, the difference of this camp and the camp in Petrozavodsk for university teams is that students are not required to do anything. So usually for them, it's they are paid by the government to get to the place, they live in some hotel-like thing, usually lower quality than hotel, but still okay. In the morning they have breakfast, then contest, then dinner, then lecture, or then lunch, then lecture, then dinner, and then some sports. For example, in the many past years, this camp takes place in a school with a swimming pool. So they can go to the swimming pool each evening, and they can go play soccer each evening and so on. So there is quite a lot of, how to say, ways to spend their time available to them. But at the same time, it is in a quite remote location, so they are not, I don't know, they can't go home in the middle and so on. So it's just basically, you go there for 2 weeks and, yeah. And there is a culture that students that were participating in these camps many times will then come back as teachers, and that's basically how it works. So many students that went to IOI then come back to this camp as teachers, and that helps to maintain, I don't know how to say, friendly atmosphere. Like every student calls every teacher by name, and everybody knows everybody, and people don't, how to say, are not shy to ask questions and so on. So basically, students feel that their teachers are their friends because they were their friends just a year ago. So because of this seems to be a very friendly and productive event, I think. Well, IOI is just the same as in all countries. You come and walk around and then write some problems, and I mean, yeah. So apart from all this, there are some preparation for Olympiad that is not official. So, okay, how do I make some more? Okay, I'll just talk about it. So in many, not in many, but in some high schools, there are extra classes about solving programming problems, where people come and first learn to write up A plus B problems, and then learn more difficult problems. So basically just learn algorithms. It is not as under such pressure as university students. So usually in a lesson of 1 hour you would learn how to solve one problem, usually like that. So it's kind of slow pace usually. But since it happens every week or several times a week, students are learning many things. In some places, it is even more than that. In some places, teams of high school students are training together with university students to solve ICPC contests. But it is only in like 2 or 3 places in Russia. I personally think that that's maybe too much for high school students, because they may not have enough time for all this and not enough energy. Because in high school, as opposed to university, you have to study, I think. Then Russian high schools have a 3-month break. Yeah, if you have any questions, just raise your hand. So Russian high schools have a 3-month break in the summer, from June to August. And during this time, many regions have some sort of, how to say, some sort of camps, but which are not like IOI selection, but rather like each day you solve problems for 2 hours, have a lecture for 1 hour, and all the rest of the day is your free time. You can play sports, you can play games with your friends, you can, I don't know, sing songs or listen to music or watch movies and so on. So this is actually a culture that is in Russia, not only in Programming Olympiad. So the standard thing is that there is a couple buildings in the middle of a forest, basically ground. So there's a fence, inside there are several buildings, and outside is a forest or a pasture or just some nature. And there some students, usually about 100, come for 3 weeks together with their teachers, and there they stay, and there they play sports and so on. for 3 weeks. I mean, I think one of the goals for this is that parents can go, for example, on vacation if they want to do that without children, or if I mean, I mean, other goal maybe is that children get to know children from other cities, because this is usually for such place. Usually people come from different cities, and you can get new friends and so on. And so I think in all it's a very positive experience for children. But recently there started to appear such camps, but that have at least some amount of education. So as I said, about 3 hours per day, or maybe 4 hours per day you are studying. This is not like very hard. And usually as I said, about 100 students come to such camp, and there are, I don't know, maybe 10 such camps in Russia, different ones. So of course 1,000 students are not as clever as the 20 students that come to IOI team selection. So the level of classes is also lower, some more simple things I explained there. And the goal is not to make people good problem solvers, but just for them to have fun through it, and maybe later they will become interested and will get to the Olympiads. This thing has become tremendously popular among students. So in recent several years there is a selection for those summer camps when you have to write a test, and then some people get selected. I don't know which is the criterion, because if they selected the top people, then nobody who doesn't have a good enough level would be able to come, and it's not the case. In these camps there are groups of different levels, but I don't know how is selection done. Yeah, so these camps are not run by government, they are run by people, so they are usually paid for. Parents have to pay for this camp. But the cost is not very, comparably not very big, so for 3 weeks it is about $800, $900, which is basically used to pay for the rent of the buildings, for the food and so on. So the teachers at such camps usually don't get any reasonable compensation. They just come there to be with children, to have fun, basically. So these camps are not for earning money, but they need money to work, because government doesn't maybe yet sponsor them. We also have, apart from all this, quite a few internet contests targeted at high school students, where some Olympiads of the same format, like 3 problems for 5 hours, or sometimes in ICPC format, like 8 problems for 5 hours, are created. Again, these are funded by government, so government pays for creation of these internet contests, and they are held. And the idea is that in order to get into this system, you need to have a city Olympiad, and you need to know about this. You need to somehow know that there is a city Olympiad in informatics. In many regions in Russia, especially non-European regions, many people just don't know. So the idea would be that we would create this internet contest as an advertisement for this Olympiad system. So people that have access to internet, and in Russia at least, it is declared that every high school has a high-speed internet. Even those that are far in Siberia, they have created high school internet for all high schools. But it's not probably as good as it sounds, and I think that in some high schools they don't allow students to use this internet, basically. But at least the hope is that most schools have access to internet, and so when we advertise the Olympiads through these contests, students will participate in them, then learn at school, and then again start to learn how to solve problems and so on, ask questions, and there is, at those Olympiads, there is some email where you can try to write your questions and so on. So basically students get enrolled into the system. So there is a philosophical question about all this. What is the goal of the system? Is the goal to find the best students to go to IOI? Or is the goal to make it interesting for as many students as possible, basically just make their life better? Or is the goal to help people understand that informatics is a cool thing? I mean, help students understand informatics is a cool thing, and in hope that they will later get education in informatics and become, I don't know, software engineers or researchers in informatics. I think different people in the system think different things about it. So I think our IOI team leader thinks that all this is to choose a team for IOI. And maybe it's good that we don't have to convince him otherwise. But I think the government is for the, and most people think that this is to show to students that informatics is it's an interesting thing, and not something that you basically have to do, like, I mean, when you're in high school, you have like a couple subjects that you like, and all others they force you to do that. Usually it's like this. And so the hope is to show to students that informatics is something where you can easily be creative and use your skills to create something interesting. And so people will like it, not necessarily participate in Olympiads. So Olympiads are used as a means to encourage the understanding of what informatics is, I think. But as a side effect, we get many good high school students that participate in Olympiads and then in ICPC. So as I said, some regions have their own classes that are not sponsored by government, but are just classes in some schools, or sometimes in university for high schoolers, about problem solving. As you might guess, this gives a big advantage to those that participate in those classes. So, I mean, if you take the Russian team to IOI, then at least 3 or 4 students will be from those schools. So the system is not fair in this sense. So basically, from one side, we try to involve as many people as possible. From the other side, people that have special training still have an advantage. But, I mean, I don't know what could we do with this, but rather than say don't train. So, I mean, that's probably the unfairness that we can live with. What else? So what happens after you graduate? Usually those that are good enough to get to this level can go to any Russian university, and most of them go to 4 or 5 most famous universities, which basically then get good results in ICPC. That's how it goes. Sometimes there are students that abandon programming contests after high school. I mean, like, I think from each IOI team, maybe one person will not participate in ICPC sometimes because, I don't know, he decided that it's not interesting, he should be a soccer player, or I don't know. It happens. Or be a mathematician, which happens much more frequently. Yeah. But yeah, from the other side, as I said, on Wednesdays there are some people that did not participate in the system, but then start participating in ICPC. So yeah, but I think still most people that get good results at ICPC for Russia are from this system. They were in all those Olympiads, they were on IOI team selection, maybe not on the IOI team, because it's just 4 people per year, but still they were taught the same as the IOI team, basically. Okay, so what questions do you have? I can try, yeah.
How old do you have to be to start competing on the CUNY?
There used to be no limit, but at one point a guy who was in 3rd grade, and that means 9 years old, competed, and there was a, how to say, so he got to Russia Olympiad, and there was a, how to say, some people, we think those are bad people, but again, some people said that when you're 9 years old, you are not allowed to spend 5 hours in front of a computer because your eyes will be damaged. I mean, because they are not formed yet, and that's too much stress for them, 5 hours before a computer. And it turns out that there is some, not a law, but there are some regulations on how many young people can spend at the computer in school. And so those were applied for Olympiads. I think now you have to be 11 to start participating. Yeah, but that guy went on to win the Russian Olympiad in his last year of high school, yeah, but only last year, so he progressed slowly but reached the highest level in the end. Any more questions about, yeah?
How many years you had when you started?
What?
How many years you had when you started?
I was 12. So I got through 6 cycles. Yeah.
In Bolivia, we have an experiment with kids.
Sorry, I don't hear you. Can you speak louder?
In Bolivia, we have a little experiment with the school kids. And a really, really big problem that we have is that the kids doesn't have a little of logic for resolve even the easier problems. In Russia, you start with these kids with something like 0.
Yes, I think in Russia most kids have quite reasonable education in mathematics, in algebra and geometry. And in particular, when you teach geometry in Russian high school, you always prove everything. So geometry is used as a way to introduce proofs and logics to students. So I think when they are 14 or 13, most students usually have this logic background that's required. So that's how we deal with that. Yeah, so I forgot to tell about one thing. So there's another step after IOI, or alternatively. So there's, after IOI team selection, there is another camp, which is called, I don't know, winter camp. Winter camp, which is 1.5 weeks. So it is held. It is held for those that were at IOI team selection but have not yet graduated, so who will participate next year. They have very similar camp to this, but in winter, so before the next cycle starts basically. And it lasts for 1.5 weeks, and again you have contest and lecture. Yeah, I forgot to tell about this, but there exist such camps in the system as well. What else? I can talk about today's problems. I think there are some people that are not interested in that. Yeah.
And those camps, do you divide them by age? Or you have an 11 years old student and a 17 years old?
Yeah, they're together. Everybody is together.
So we the same problems?
Yeah. When I was 12 and I came to this selection, so of the, how many, like 36 problems, I maybe solved 1, but I don't think I even solved 1. I mean, yeah. And usually for many young students are on the bottom of the scoreboard. But they get to listen to lectures and they get to practice and then they grow. So there are no special problems created for the weaker students. Sometimes the lectures are split. So sometimes there will be one lecture for those, for example, lecture about short spots in graphs for those that don't know how to find them, and there will be a lecture on, I don't know, matroids for those who know about short spots so are not interested. So sometimes lectures are split, but most lectures are also the same for all.
In the previous speech, you told us about ICPC, but we didn't have any major difficulties when participating, because you knew everything from the IOI state, right?
Mostly, yes.
So, but so how your knowledge begin with DIY? Can you tell us more detail your how did you receive so much knowledge in these games? How were your experience and difficulties that you encountered in these games?
Okay, so so when I was in those first camps, the structure was usually like this. So we had a lecture on some topic like dynamic programming, and then the next day the contest will have 2 of the 3 problems on this topic. So you get to practice, and then in the last day of the camp, there was a special contest when you could submit problems from all previous days that you didn't get full score on. So you could try to. I think this idea that you practice what you heard in the lecture was very helpful to understand how to write programs. And I think another important thing is you see, I was 12 and everybody else was like 15 or 16. So they didn't want to talk much to me. They wanted to talk between themselves. But still some of them helped me and explained things to me, and I think that also helped a lot, because with a teacher, you still feel that, I mean, my question is too stupid, I won't ask it. And when you ask your friend, I mean, it's okay, so people explain to each other. And because basically you don't have anything anywhere else to hide, how to say, because everybody is together for 2 weeks, so, I mean, people get talking to each other anyway, so, yeah. And I think that was the core 2 parts, so that we could practice on the topic of the lecture, and that I could ask what I didn't. If I'm unable to solve a problem, I will ask many questions to the older guy, asking how to implement this, what is wrong with this program, and so on. Oh, computer games are forbidden at those camps. But students still manage to play them sometimes.
Days of you come here, because there is POE training. One problem is resolved with Voronoi diagrams.
Well, the answer is yes. First, you were not required to know what Voronoi diagram is. You were required to get the idea that you split your polygon in half and to find which point is closest. And second, all the topics. So, for example, when I was in my last year, one of the lectures was about factoring polynomials over ZP. So, I mean, so you have polynomials in ZP. I mean, these coefficients which are remainders modulo P. And you have to factor it. There is an algorithm to factor that called Berle-Kemp algorithm, and we were taught that. So Voronoi diagrams are also taught at those camps. There are some very complicated lectures and complicated subjects there. Usually not all students understand them, but they help to, so that basically those that go to IOI know everything about standard algorithms, so they need to have something to keep their minds working. So there are usually, each year different, but there are usually some lectures on very complicated subjects. So yeah.
Here in Brazil, we have Olympiads of informatics, I think mathematics, physics, and chemistry. But all of them, but informatics, you need to study it through our universities. Chemistry, physics, and mathematics. So I think the informatics Olympiads is less known than the others. Does it happen in Russia as well?
I didn't understand. So for chemistry Olympiad, for example, you have to study for what?
Because if you have an exam called vestibular that you do to enter the universities, and in this exam, you have chemistry, physics, and mathematics, and other things. And you have Olympiads of the subjects, but you don't have to study informatics at the universities. So, Microsoft Olympiad is less than for the others.
Yeah, I see what you mean. Yes, I think something like that happens in the sense that for mathematics or physics or chemistry, in almost every high school you get a decent level of education for that. And for informatics, partly because it's also not required to most universities, the lessons may be as bad as learning how to launch Microsoft Word. I mean, yeah. So there is this problem, and that's why we need the internet contests and so on to try to find students even who don't have good informatics lessons.
So, informatics does make part of the basic curriculum in Russia.
Well, but it is not specified which informatics basically. Yeah. So yeah, but it is required to be in every school for I think one lesson per week for 5 years or something like that. But sometimes it's not very good.
But informatics classes teach algorithms or
Differently. Some schools teach algorithms, some schools teach programming, like, I don't know, during the year they program some large program with user interface and so on. Some schools teach Microsoft Word. I mean,
Brazil, it's like that. That's Microsoft.
yeah, I mean, there are attempts to create a list of what students need to know after completing high school informatics, but there is not. I think they are not still a law, and they are not agreed on. So there are some schools that don't teach anything important yet. So, but I think there is a push from people that run those Olympiads also to create a good textbook for informatics that will and create a required minimum that what needs to be taught in high schools. So hopefully we'll get more algorithms and programming classes later.
And are the students divided into groups like math, physics, chemistry group, or
it's
Russian, something like that?
So usually not. Usually, so high school in each grade, you have several classes or groups. Each class is about 20 or 30 people. And usually in each class, all subjects are the same. So they are not divided. The only difference is foreign language. Sometimes one part of the class studies English and one studies French, for example. But for all other subjects, there's another difference. We have this subject called, I don't know how to say it. Even in Soviet times it was called labor, but now it's called something like technical education, something like that. And there boys are taught to, for example, make something from wood, like use, I don't know the name, so basically to cut something from wood and make some useful things. And girls are taught to cook. So we have those classes, yeah. Which is also separate for parts of the class, obviously. But no, informatics is the same. In some schools, there are specialized classes where in class, in addition to the common part, you have some additional lessons. So they don't replace the common part, but rather in addition, for example, in my class, there was additionally 4 lessons of mathematics per week, in addition to the basic level. A basic level is 6 lessons per week.
All of these competitions are advertised in schools in Russia.
Usually we rely on the informatics teachers. So in schools where people know what is Olympiad, usually the informatics teacher will gather all students and say to them and say when is the city Olympiad, how to get there and so on. In schools where there is no such person, I think the Ministry of Education sends there is a special kind, like official letter to the president of the school and asking him to put an advertisement on the board near the entrance to the school, inside the school, so that students can read it. And usually these official letters are taken seriously because basically they can check that you have put this advertisement, and otherwise they can punish you. So, yeah, the school system is very, how to say, authoritarian. So it is very controlled from the top. Yeah. If you want to publish something, you do it this way.
Is there any advertisement targeted to parents?
No. No. On the Olympiads themselves, when you come to an Olympiad, so usually a student goes to the Olympiad and parents have to wait somewhere. So there is usually some event for them, like somebody gives a lecture, and there might be some advertisement of other Olympiads, of extra classes for programs that take place in the city and so on, or of other schools that have interest in programming and so on. But there is no advertisement that can be sent to your home. It's not like that.
Besides the camps, did you have help from someone to study for the IOI?
I didn't. So I had this 2-week camp, this 1.5-week camp, and all those Olympiads, and that I think was enough for me. We're not willing to do more. Maybe if I did more, I would have become like Gennady Korotkevich, which is a Belarusian guy who have won the IOI recently, and he's like 13 or 14. He seems to train a lot.
Do you think that the structure is the best, or there's something you would say?
I don't think I'm clever enough to decide on this subject, actually.
Just
How to say? So maybe what I would like is to have some more. So what I like about Olympiads that are in the structure is that those are not over the internet, but you have to come somewhere together with your team, and again, it helps to talk to other children that have similar interests and so on. I think that's very good for children. And so the only thing that I might want to change here is to add more Olympiads to it.
So, in general, to get started, schools do teach enough programming in order to, take part in the Olympiad or not. Do students in general need to be something like self-taught?
No, I think to take part in the City Olympiad, if a student, so schools will teach you how to, how to write simple programs, and then if you have interest, you will learn something by yourself. So I think you still have to learn something by yourself. You have to be more interested than what you give in classes. To get to the City Olympiad is free, but to get through the City Olympiad to the next level, I think you still have to get some. But it's not very much. So you have to, try to write some programs by yourself, for example. I think that's enough to get to the Russian Olympiad, actually. If you have some experience of that, and you don't know how to solve mathematical problems, then together you can solve the programming problem. At least in high school, where you have a lot of time for it. In ICPC, basically you need to, for most of the problems, you need to know almost all solutions and only construct some parts. In high school, in 5 hours, you can just invent the solution. Yeah, that's a good point. So we try not to make it required for all these participants to become too involved in it. So we try, as I said at the beginning, not to require them to train a lot. But of course, it's impossible to make people who do train a lot perform worse. So, but we try, and I think it kind of works that people that don't train will still can participate up to some level and have fun and yeah.
Do you have any notion of the numbers involved? I mean, how many students take participate?
Well, I can go from bottom to top. So this is 4, this is 20 to 30, this is about 150. This, in each of those, I think about 100, so total is 1000. In each of those, it varies greatly by region. In some regions, basically 5 people come and 5 people go to the district Olympiad. And in Moscow, the city Olympiad has, I don't know, I think it has about, so in Moscow, the city Olympiad itself has about, I think, more than 200 participants. So I guess the total number of participants in this system should be several thousand. But I don't know. I can try to look it up. Maybe there is some published information about this. Okay then.
Yes. Do you know when this government censorship started?
I think it started with Olympiads for mathematics, somewhere around 50 or 1955.
So
It's a very long tradition. Yeah. So yeah, in mathematics, we have like kind of 60s or 70s. So the City Olympiad has a number, and in mathematics it's very large. There has been a lot of them already.
Could you tell us a little bit about your experience that you had, all the way from where you began taking the Olympiads and the surprise you had, disappointments you had, everything? Well,
Okay, so when I came, as I said, I passed the first several levels by being too young. Then I got to this camp. So then there I didn't solve almost any problems. I listened to lectures, but also not very much. I played quite a bit of computer games in that camp. And so in the end I didn't learn much. So the next year I made it to the Russian Olympiad by the merit. But in the Russian Olympiad I was still not, I was like in 30th place maybe, so I was still not to get to this team. But I still, since I was still too young, they took me to the team selection again. And I think that year, in 1998, it was the kind of turning point where I studied a lot of this camp, listened to all the lectures, tried to understand them, asked questions. And the next year, I got 4th place in the Russian Olympiad and almost made it to the IOI, but I got 5th place at the selection, so didn't make it to the IOI. And starting from that, I was mostly, so before this, I was kind of learning everything. And after this point, I was friends with all the teachers because they already all knew me. And so it was more, this event, this selection camp was more like having fun for me. And because of that, I think I also progressed very good because it was not, there was no pressure at all after this. And yeah, so what I saw was that because I was at those camps for very long, I seen several generations of other participants. And I saw different people that, for example, there was a guy who in his next last year came to Russian Olympiad, didn't solve any problem there, but he decided that he liked it. He studied a lot through the year and then won the Russian Olympiad next year. So not International Olympiad, he won the team selection. International Olympiad he was like third, and then he won the team selection. So he really progressed a lot in 1 year by just studying a lot. And when looking at him, I was thinking maybe I should have done that several years ago. But yeah. Well, what else? I mean, I went to 3 IOIs. So it was the first time I was abroad, so for me it was very interesting. But at the same time, at the IOI, I did feel the pressure that I need to do my best, and so because of that, I didn't enjoy the touristic part of the IOIs much, which I think I regret now. I should have be more relaxed there, because anyway, you can't do better than you can at the contest itself, and the pressure I think only makes it worse. What else? So I don't know. So as I said, I didn't study the problems much apart from these trainings. So in my usual life, I studied mathematics mostly, as it was the specialization of my class in high school. And then what also was good about those camps is that I got to know people from different cities, which is quite unusual. Usually you only know people from from the neighboring several homes or from your class. So I think even now it's often great that I can, when I visit some city, I can. I have friends all around Russia, so I can, when I come to some city, even here I have friends. So when I come to Brazil, I can feel very good. So I think that's a great thing that I got from the programming contests. What else? Well, when I got to the ICPC system, I think that as I got to second place, I think I missed quite a few chances. I don't see. Sorry. I think I missed quite a few chances, and I could have had trained much more and get first place in this ICPC contest. But I didn't. I don't know. I was not sure at that point if I should invest my time in this rather than research. So I'm still not sure if I could, for example, become a full-time coach of Russian teams instead of working at Google. I don't know, but currently working at Google seems more exciting to me. Yeah, maybe that will change. Did you ask about kind of problems? Just wait a moment. Okay, so if you ask about problems that I encountered.
In what grade does informatics education start in Russia?
6 out of 11. So it's, and I think it ends in 10, so we don't have it in the last grade. I don't know. I mean, as I was, how to say. So when I was in high school, I had all excellent marks for everything, and because of that, I did not have many friends in the class. Because basically people thought that I am kind of the guy that always reads books and something that not interested to play with me. So again, those camps helped me to feel more like myself, because all other people were like me. And I think that was also a good thing.
That the good participation of Russia in the IOI is due to the level of mathematics at high school that many countries doesn't have. Do you think that
the good performance in Olympiads is due to the level of education in high school? Yes, I think yes. I think that's because if you have better education, you have more students to choose the team from. And so basically at each level, if you have more students at the low level, then you have more students at the second level, then you have more students that are IOI level. So the pyramid is increasing if you have more at the beginning. So I think, yeah.
Could you explain the problem of today?
Okay, so we can declare this talk over and then talk about the problems of today, sure.
Alguém quer fazer mais alguma pergunta? Todo mundo satisfeito? Tá bom. Ninguém tem mais alguma pergunta?
Era péssimo, não fala quando Até Brasil tem informática.
Não, fala em português também. Ah, é, tá.
In the Brazilian informatics LPS, how many students participate?
7,000, but we have a different system because we have we separate students and to the first here we have a second school and a high school. Okay, for the high school students we have 200 guys that compete, and for the second school we have 6,000. 6.000. Pô, eu falei certo? Sei lá, todo mundo. Não é milhão, é 1.000. 6.000.
And a lot of younger people participate.
In the second part. So, in high school we have guys with 50 years.
How many of those are programmed? There's a logic test. There's a program. Quantos fazem parte da programação mesmo? Tem uma parte lógica.
200 pessoas. Tipo, Gabriel, ó, quem é da UBI levanta a mão. Gabriel, são os seus nomes? Felipe, Marcelo. Quando vocês começaram? Fala aí. Tipo, o Gabriel começou com?
Cara, eu fiz a prova ciência de programação e lá.
Tá, oitava. Oitava, quem mais começou na oitava? Oitava. Tipo, e se você pegar esses caras que estão levantando a mão, eles foram os melhores na época deles. Tipo, dos 200 que participam, poucos começam na oitava. Acho que vocês, na seletiva que vocês foram, vocês viram, sei lá, tipo, 2 caras da oitava série, 3 caras da oitava série. Que eram bons assim de continuar. Hoje a gente já tem, tipo, hoje o Brasil já tem um moleque com 13 anos indo para IOI. Mas é claro que não é universidade. O quê? Então, é isso, tá bom? Peço.
Yeah, actually, I think that several thousand was a bad estimation. I think several tens of thousands would be more.
Okay, thanks. I will stop.
I don't think. I mean, you just need to be in a good shape because basically, you've done all the trainings you could. The finals are in the weekends and several more days. So, and if you do not go into the finals and for next year, well, I think you should try to have some regular preparation, like once a week, for example, to try to solve the problems and to discuss them afterwards to see what you can't fully solve. Try to ask for solutions at the forums, for example, where many people will hopefully answer you. And yeah, I mean, I think there is, as I said, there is no secret to the rational linked preparation. It is just preparation. Yeah. So. Okay? So problems. Problem A. Do I need to explain problem A? No? Okay. So problem A was about reading the input and finding the equal signs and finding symbols around them, basically. It was nothing more than that. Okay, problem B, which was the culmination of this contest. Okay, so problem B. You were given an algorithm that does quicksort. More specifically, you were given a very specific algorithm. So I'll write some key parts. So we have key equals A left plus right. That's how we choose the pivot for quicksort algorithm. And then what quicksort does is while greater than equal to G, while AE is less than key plus E. So the history of this algorithm is that's how quicksort is implemented in the examples for Borland-Pascal. When Borland-Pascal came with some example programs and it had quicksort. So basically all participants of rational impacts in the Pascal times just copied it from there. So that's because this story has some importance, I think. But I think not only in Russian actually. J. Then E less than equal to G. We swap two elements. And then we do plus E minus G. And in the end we sort two segments, one from E to right and one from G to left. So in order to, and we need to create a test case where the number of comparisons of these two comparisons were compared to elements of the array. Yeah?
If you want to use the other one, you are required to.
Hmm?
You are required to be almost.
Yeah, but I think,
choose.
yeah, I mean, I think one word is enough. So, and we need to maximize the number of comparisons in these two lines by giving a very better rate. So, what we need to understand first. So, how would one solve this problem? It is kind of obvious that if you construct the array in sufficient way, you can achieve any separation into these two parts. So basically, our solution would look like, so we construct our example we construct the worst possible test case for these two parts, and then combine it into a worst possible test case for the whole algorithm. That would be the general idea. Then, in order to understand it more clearly, let's first think, what do this I and J mean? So what does quicksort do? Basically, it selects some element key and then splits the array into two parts. In the first part, all elements are less than key, and in the second part, they are more than equal to key. So it splits the array into two parts. And it helps to understand that in the end, pointer I always points here, and pointer J always points here. It is always the case. Okay, right? I mean, is it clear? Hopefully yes. So, what we can notice, so let's forget about the recursive calls. Let's take a look at this algorithm. What is the maximal number of comparisons we can get? I claim that it is basically n plus 2. It is the maximal number of comparisons we can get from one pass. It is n plus 2. For all n except 3. and 2. So for all large n's, it's n plus 2. Why? Because basically every time you do a comparison, you do an increment. Or every time except the last time. When this comparison returns false, you don't do an increment. So the number of comparisons is one more the number of increments. And the same here. But the point is, if after this condition is true, then you still do 2 increments. So you still have one comparison per one increment, right? So the only way you can have more comparisons is when this condition relates to false, and then this condition relates to false. But that can happen only once, because after this the loop will break. So you can get the number of decrements plus a maximum of 2 extra comparisons. This is the maximum you can get. And the total number of increments and decrements is easy. So I starts here, and ends here, and G starts here, and ends here. It's quite easy to see that the total number is always n. So, I don't know. If this element has number 0, and this element has number x, and this element has number n minus 1, then J changes from n minus 1 to x minus 1, and I changes from 0 to x. And then we get this, and we have n. So the maximum number of comparisons for one inside this one big loop is n plus 2. But for small values of n, for 2 and 3, you can't get this much. So for 2 and 3, the maximum number of comparisons is 3. You can just check it by basically checking all possible arrays of length 2 and 3. So for length 2, to get 3 comparisons, you can, what can you do? So you can, for example, make array of 2, 1, and then you get 3 comparisons. Because you get 1 comparison here and 2 comparisons here. Because 1 is less than 2, and then you switch left. So this is for n, so I can write here, right?
Yeah.
So for n equals 2, the array would be to 1. For n equals 3, again you can just check, or it was given in the problem statement actually. The worst case is 1, 3, 2. Because in this case, what will happen is 3 is chosen as a pivot, and then yeah. Is it okay? So I think I'm not sure why this is the worst case, but I guess if you check all cases, it will be. But what happens to this array in quicksort? So we choose 3 as key, then we do this. So E gets to 3. So we have done 2 comparisons. Then we do this, and we done 1 more comparison, and it stays here. Then we swap them, and then the loop ends. So we get this array, and then we sort 1, 2. But when we sort 1, 2, key gets equal to 1. Then we this comparison is related once. Oh, and this comparison is related twice. So yeah. So for n equals 2, both arrays are good. Because of this, 1, 3, 2 is a good array for n equals 3. And for all other n's, I claim that you can always reach n plus 2 comparisons. How can you reach n plus 2 comparisons? Let's take another look at this. How can you not do n plus 2 comparisons? In order to not do n plus 2 comparisons, it must happen that you don't have 2 extra comparisons here. So it must happen that this condition relates to true, and then after you do this condition relates to false. So this is the only way not to have n plus 2 comparisons. So we only need to avoid this situation where we basically swap two adjacent elements. For example, one way to avoid it is to, for m at least 4, we can put the maximal element into the middle, so the key will be equal to maximal element. Before we do this, we need to understand. So, what we want to do is we know that at this level there are maximum of 3 comparisons, at this level maximum 3 comparisons, at the next level maximum 6 and 7, 8 and so on. So intuitively it seems that the best way, the worst case, would be if one of these segments has length n-1 and another has length 1. So each time n is reduced by 1. Intuitively it seems the worst case. How would one prove that? I think because if you do it that way, then the total number of swaps will be, here it will be 3, here 6, here 12, here 19, here 27, then 36, then 46. So basically you would get a partial sum of this number of each step. So if you start with n equals 7, then you do 9 comparisons, then you get n equals 8, then n equals 6, you do 8 comparisons, you get n equals 5, you get 7, and so on. So this will be the total number of comparisons if we manage to do it like this. And it's quite easy to see that these numbers, so if we were not to split it into n-1 and 1 and split it in some other way, like n-5 and 5, then we would need that, for example, this number should be less than this number plus the first number, or this number plus the second number, and so on. And it turns out that this is not true, because this function is, how to say, convex. The change is always growing. So because of this, split into n-1 and 1 is always the best, because, how to say, so you have to, so let's name this number f of n. So this is f of 3, this is of 2, this is f of 3, this is f of 4, and so on. And so I claim that f of n is always more than f of n minus 1 plus f of 1, and more than f of n minus 2 plus f of 2, and more than f of n minus 3 plus f of 3. Why is it so? Because the difference between f of n and f of n minus 3 is more than f of 3, because basically f of 3 means 3 steps at the top, and f of n minus f of n minus 3 means 3 steps at the bottom. And at the bottom the steps are bigger. So that's kind of the intuitive explanation, or maybe you can make a formal proof of it, that you should always split into n minus 1 and 1. So, again, returning to our case when n equals 4 or more. In order to split n minus 1 and 1, for example, you can use the following idea, that you will put n into the place where, so that key gets equal to n. That way, in this array, n will be the array will be split into n and all lower elements in the first part. And let's try to understand, is it possible that we get less than n plus 2 comparisons in this case? So what will happen in this case? Key gets equal to n. Then I, in this loop, I will go up to n. So I will point here. J will stay at the last element. we will swap them. So n gets here, and then shift them. So j gets here, and I gets here. And here we use that n is at least 4. So here we still have that e then is less than equal to g. So the loop continues, and then e gets moved to here, and there are 2 extra comparisons performed that we need. There is extra comparison here, and then the loop ends. So it's important to see if the size was larger, and we have put n here, then again after the swap, this index will go here, but still we have avoided the situation that we swap 2 adjacent numbers. Because of that, we get n plus 2 comparisons per level. It's important that we use n and not 1 here, because for n equals 4, if we try to put 1 here, in order to split into 2 parts, how to say, okay, what will happen if you put 1 here? So e points here, g will go down to here, we are going to swap them, we put 1 here, increase e and decrease g. And after that the loop ends. So if you put 1 here, we lose 2 extra comparisons. We don't get into this loop second time. But from this example we can actually learn that I was wrong here. So it is not always the case that we split into those 2 parts. Because in this case 1 has got into the left part. So I guess I should have formulated this better. So let's say these are less than equal to key, these are more than equal to key, and the e and g still point like this. So I claim that this is true. Okay. So 1 would not work, because we would lose for n equals 4, 1 would not work. For all other n's, 1 would work as well. But for n equals 4, you have to put 4 in the place that chooses the pivot. So, what is now, how do we solve this problem? Let's have a method. Let me erase the quick sort parts. No. Methods that returns, for example, I don't know, okay, get of let's first not try to think about the running time, so let's have a method that returns a vector. Vector of int get int n. So this method would go like if n equals 2, return 1, 2. If n equals 3, return 1, 3, 2. Otherwise, or we don't need otherwise. So after we handle these 2 small cases, what we do is we basically first say small. So we get a solution for n minus 1. Get of n minus 1. So this is the array that will cause the largest number of iterations for n minus 1. And how do we need to change it? We need to remember what happened to our array again. So we had n in position left plus right divided by 2. And what was happened is that n got swapped with the last number. And then that is the resulting array. So what do we need to do with this array? We need to find the position of the pivot. So position equals left plus right divided by 2. Left is 0, right is n minus 1 divided by 2. And we need, then we do small of n minus 1 equals small position equals n return small. So what we essentially do is we take the number that was at this position, put it in the end, and put n here. Then when quick sorting calculates this array, it will swap those two numbers, get the worst array for n minus 1, and invoke for it. So this is the solution. And as you see here, we can in order for this to run in linear time, we can avoid returning a vector, but rather change the same vector each time. So we can do it like this, for example, or like this. In order, because we basically, the only change that we do to a vector is we add a new element in the end and put n. And that can be done effectively with a vector. Okay, so what questions you had about this problem? So, most people that got, I don't think anybody got to the time limit stage in this problem. I think everybody got wrong answer. For most people it was n equals 4. And for some people it was n equals, so the next stage after 4 was 100. And for 100 you were getting, most of you were getting, so the optimal number of comparisons for 100 is like 5,000 something. 5,000, I think, like this. And you were getting 2,000 something. So you were kind of way off the optimal number of comparisons. So what else? What I want to tell about this problem? Some of you had a whole hour to do this problem. So I think what I would do if I were in your place is it's easy to solve this problem for small n's by taking all permutations and running the algorithm and counting the number. And by doing this, you could avoid getting the wrong answer on n equals 4 at least. You could check your algorithm yourself and find bugs quickly. Because if you have a slow solution that works for n up to 10, you can at least try to figure out a pattern, or at least you can check that your fast solution works correctly and helps find new bugs in it. And this is an idea that happens in other problems as well. Sometimes the only way to find bugs in your solution is to write a deliberately slow solution. This is no past test cases, but it will help you find the problem with your solution, because you can compare them on the various test cases and see the difference. We call this approach in Russia stress testing, when you stress test your solution against a stupid solution and find the difference. So, usually it's not the best way to do it in the beginning of the contest, but when you have for example, when you have one problem that you need to complete and nothing else to do, and this problem you have wrong answer, then it's sometimes the best thing to do, to write a slow solution to find the bug. Okay? So what questions about this solution? So, if only you could, this is not the only possible solution, of course. So you could put not n but 1 in this place, but you have to do something differently, and you can't use 1 for 4. So if you have a special case for 4 as well, what is it? I think 1, 4, 2, 3. After this, you can use any method. You can put 1 instead of n, but then you have to put. So if you put 1 instead of n, you have to shift your array, so it's less convenient. Okay, so no questions? Okay, what other problems we have? Problem C. You're given a graph with at most 25 edges, and you need to find the length of longest path in it. I think you could solve it anyway, like backtracking, trying all possible paths until you get, until you find the longest. Or you could use, so you could do a dynamic programming over what edges are already used and where you are. All this will pass the time limit easily, I think. For dynamic programming, for example, if you have 25 edges, then it's seems that you have 2 to the power of 25 states times 20 times 25, but in reality of those, much lower will be possible, because those edges should form a path, and in reality the number of states that will be non-zero in UDP will be very small. So if you do transitions only from these states, then you get a fast solution. But I think backtracking also possible. So you see, to check that the given graph has a path that passes through all edges is a solvable problem. It's called Euler path that passes through all edges. And you can check its existence by using a criteria. And you can find the path using an algorithm similar to DFS. But when there is no path passing through all edges, I don't think there is an efficient algorithm other than backtracking or DP with 2 to the power of some states that will find the longest path. Because it turns out that, how to say it turns out that if there is the path passes through all edges, the problem is zero. But in this case it's not. Okay? Okay. Problem D, do I need to explain problem D? Did anybody not get accepted for problem D? Because of people who submitted solutions, everybody accepted problem D, I think. So the only case if you were not submitting solutions. Okay, so I will not explain problem D. Problem E. You were given a description of a tournament, yeah?
I'm going to let the server on for send these solutions. I'm going to let the server on for some time.
Yes, I mean, I will get the server on for today's evening when I get back to the hotel, but that will be late. Then it will be on all night until today's morning. Then I will travel to Russia. And then when in Russia, I will be in Russia on Tuesday. And then I will run it until Friday, until I leave for Harbin. So from Tuesday to Friday, you will be able to submit solutions anytime, unless it breaks, as it usually does. But I will repair it. Okay. So problem D was about you were given a structure of a tournament. Structure of a tournament. So you have 16 teams, then they play like this. And so on. So the way this problem is solved is basically for each level you calculate the probability that this team gets to this point. So that Italy qualifies for quarterfinal, or that Brazil wins the semi-final, and so on. And you do it by basically, so in order to find the probability for Italy to get to this point is 2. How do we find it? We find the probability that Italy gets to this point, and then we need to find the probability of Italy winning this game. And for this, we need to find out who will be this team. So for each team of this part, we take the probability that they get here and multiply that by the probability that Italy wins of that team, and add this together. And this gets the average probability that Italy wins in this game. And by this we can find the probability that Italy gets here. So the formula would be so let's say this is position X, this is Y, this is Z. So probability of Italy Z equals probability of Italy X times sum over all teams probability team Y times probability of Italy wins over team. So that's basically what you need to implement. So I think most problems most from that as a solution were wrong formatting of the output. Some people forgot the percent sign. Some people forgot to indent the country name to 10 characters or something like that. Some people have problems with those string-line endings. So again, what questions do you have about this problem? Okay. So problem F. You needed to find the decomposition of given number into the sum of two prime numbers. The sum of two prime numbers. So the way you do this, first you calculate all prime numbers up to 1 million. There are several ways to do that. Either you go up to 1 million and check each number if it's prime by trying to divide it by all numbers up to square root of this number, or you use a sieve of, I don't know how to read this name, but sieve of Eratosthenes, or I don't know. So the sieve where you start with all numbers and check out all numbers that are divisible by 2, then check out all numbers that are divisible by 3, and so on. So that you are left with only prime numbers. That runs in faster time, in n log n, or even n, I don't know. And after you find all prime numbers, you just go over the given list and run over the prime numbers until you find such numbers that the number n minus this number is also prime. Because, so yeah. And one might ask, why does this run in time? And that's because basically for almost all numbers there are many, there are many possible decompositions, so you will find one quite early. It is rare that in the decomposition the first prime will be very big. So for example, if you are worried that in the input the worst case is repeated several times, you could, again, for each number from 2 to million, calculate the answer by doing this loop over first prime number. And that way you will process each case only once. And then when you read the input, you just write the output. So you could just pre-calculate the answer for all numbers before reading the input. And that will be fast because for almost all numbers, the answer is found almost instantaneously. And then you read the input and write the output. Is it? Yeah, okay, so I think it's clear. Yeah.
Is there any case that the answer is that there's no decomposition?
Nobody knows. No, but for numbers for up to 1 million, no, of course. But for any numbers, it's an open problem. I think you get like $1 million if you solve it. Either way. Okay, so problem G, about the nearest number. You are given a matrix. You are given a matrix. Come on, just two problems and it's over. You are given a matrix where some cells have numbers and all others are zeros. And then you need for each cell find the closest cell with a number according to the Manhattan distance. So the distance between these two cells is 2, and with these two cells is 3. So distance is measured like horizontally then vertically. And for each cell you need to find the closest number to it and put this number into this cell. And if there are several closest numbers, you don't need to put any, you need to put 0. So how to solve this? Well, obviously the stupid solution does time out. So you can't for each cell just check all numbers, check distances and find the minimum one. So how would we solve this? We will use breadth first search. What does it mean? So we start from all numbers. Then for each of those current numbers, we put this number into 4 neighboring cells. So here we will do this. Oops, why did this 2 appear here? So as you can see, for some cells there is a conflict. When there is a conflict, we will put some special value here, like -1. And then we continue spreading and we continue to spread minus 1. So when we join 2 and minus 1, we get minus 1. 1, here 2, minus 1, 3, and then here minus 1. And then we replace all minus 1 by zeros and we got the answer. Basically, it's as simple as that. What questions do you have? So the trick was, so for example, how do you tell that in this case you got 2 and 3 and you put minus 1? And for example here, after the first step, when you go from this 1 to the top, there is already 2 here. Why don't we put minus 1 there? So the rule is, if this number was put at this step, and we get another number for this cell, then it should be minus 1. But if this number was put earlier, then we shouldn't change it. That way, for each cell, it will have the number that got to this cell as fast as possible, and that is exactly the closest number for this cell. And if there are 2, then they will get simultaneously, and we will have minus 1. That's it. Yeah, so in order for this to run fast, you create a queue of cells, and then go through this queue, like in breadth first search. Go through this queue, when you add a new number, you put it into the end of the queue, and then you take it from the beginning. In the next number, so like breadth first search. Okay? Okay.
Yeah. And that runs in n squared.
Yeah. Squared?
Because I solved it in completely different manner in cube.
And cube?
For each cell, pre-computed the first non-zero cell to the left and to the right.
Yeah.
And then after that, for each cell, I tried for all lines. I saw which was to the left, which was to the right, and use that distance, some that distance, and got the minimum. Okay.
So from each cell you go to top and to bottom. For each of those cells you know the closest cell to left to right, and then you can find the minimum.
Yeah.
Yeah.
And that's
Yeah, that's not cute. That's a good solution.
The end was small. I didn't try to think in n squared solution because the end was small.
Yeah, n was 200.
Cube is good, so.
Yeah, the cube was good as well. You can solve it in cube as was told now. Okay, and the last problem about team Q. Is Andres here?
Yeah.
Andres, can you explain the solution? Okay, so I can repeat the words more loudly.
Okay.
Because I didn't read it.
So basically the idea is to have a vector of q's like this. One q for each team. So this q would, let's say we a q person, we have some teams.
Team 0 is 1, 2, 3. Team 1 is probably 4, 5, 6. No. Okay, it's 7, 8. I promise to read it aloud. Have to.
Okay, so let's say you and Q, for each team, you know which Q belongs to it, which is obviously this index. So let's say you and Q 3. So you just started here in this team's Q. And also, you add it into a priority queue, which is formed by a pair. The pair is what team and on what time it was in queue. So it would look something like this. The priority queue would have team 0.
No, it should be the other way around. Time.
So let's say after that, you queue person 7. You add the time
Team 1.
team 1. The person 8. So this is the tricky part. When you are going to queue someone who belongs to a team that had already been queued before, you set the same time here, the same priority for this guy. And when you queue, you just take this pair with the shortest time, so this guy, and print this 3, and pop it out of the queue. Then, when you queue someone from team 0 again, the priority would now be 3. Say, and this is basically it. So, it's 2 operations. When you queue, you have the pair with time and team. The time can be either 2 things. Can be either the biggest time step that has happened, or the time step of someone from my team who was in queue before. I don't know.
Yeah, I think it's okay. So basically, what we do is we remember in which order persons come in each team separately. Like we have separate queue for each team, and then we have a priority queue where for each team we will have as many entries as there are people in the queue from that team. And all entries will be the same. The time of the entry of first person of this team and the number of the team. And when we add the new person of the team, we check. If there is somebody else from his team, then we take the time from this previous guy. And that corresponds to the fact that he stands into the queue behind the last guy of this team.
So I think the total complexity would be for each queue operation, you just have to find out if there was someone involved.
Yeah, so it should be
Almost order 1. You just add it in a map, and then log in for both operations.
Yeah, maybe in login. I think you can even do this in N if you want to. Because the key in your priority queue is number from 0 to N. So you can implement your priority queue as an array of queues again for each priority. And that way the total running time will be N, not N log N. Because, but it is not important. So yeah, that's it about the team queue problem. Questions? Okay, so we're done with the camp. I thank you for all the problems that you've solved. I think you did a great job, and I think you can still do a better job if you solve the problems after the camp. And good luck at the finals, obviously, for those who come there. And for those who don't, good luck at the next finals, or the next finals of the next finals. And in the next finals, after next finals, after next finals, they will be in St. Petersburg in Russia, so have a good goal to prepare for. Okay, so thank you.